Hello class, welcome again to Electric Circuits 1. This time, let's have the basic laws for our electric circuit theory. In this lecture series, we'll cover the basic laws in order to determine the values of the current, voltage, and power in a given circuit. The basic laws of electric circuit theory, these are the Ohm's law and the Kirchhoff's laws. And these two laws, they form the foundation upon which electric circuit analysis is built. Particularly, we'll have 5 topics for this lecture series. And let's start with the Ohm's law. Materials in general have a characteristic behavior of resisting the flow of electric charge. This physical property or ability to resist current is known as resistance and is represented by the symbol R. The resistance of any material depends on its cross-sectional area and its length. This is the cross-sectional area, and this is the length. In mathematical form, that's R is equal to rho L over A. Rho being the resistivity of your material, expressed in ohm meter. Based on resistivity, a material can be classified as a conductor, a semiconductor, and an insulator. That current resisting behavior of a material is modeled by the resistor. And its symbol is this one. A resistor is either fixed or variable. As the name implies, fixed type resistors has a constant resistance. There are 2 common types of fixed resistors, wire wound and composition. Usually, wire wound resistors have low resistances, while composition resistors like this carbon film resistor have large resistances. As the name also implies, a variable resistor has an adjustable resistance. Examples of variable resistors are the potentiometer and the slider. Now take note of the symbol. This is for the variable resistor. Then this one is for the fixed type resistor. So the difference is just this arrow. The German physicist George Simon Ohm, he discovered the relationship between the current and the voltage for a resistor. This relationship is known as Ohm's law. Ohm's law states that the voltage across a resistor is directly proportional to the current flowing through the resistor. This is mathematically expressed as V is equal to IR. It can also be useful to remember Ohm's law using this triangle. If you want to find V, then just cover V and you'll only have IR, which means that V is equal to IR. If you want to solve for I, then just cover I and you'll only have V over R, which means I is equal to V over R. So the same also goes if you want to solve for R. Another thing to note is that the direction of current and the polarity of voltage must conform with the passive sign convention. If current flows from a higher potential to a lower potential, then V is equal to IR, just as shown in this figure. If current flows from a lower potential to a higher potential, then V is equal to negative IR. Let's have this example. The essential component of an electric kettle is a heating element, which is a resistor. So this heating element is a resistor that converts electrical energy into heat energy. The question now is, how much current is drawn by a kettle with resistance 120 ohms at 240 volts? Again, so from the previous slides, Ohm's law is equal to V. Ohm's law has V equal to IR. So from this, we just have to rearrange. We are asked for I, then and I is equal to V over R. So that's equal to 240 over 120. Hence, I is equal to 2 amperes. From this, we can say that the current draws, the electric kettle draws a current of 2 amperes. How about this one? Let's try for a sinusoidal source. This time, let's have the electric iron. An electric iron with a 24 ohm heating element is connected to an outlet at V equal to 220 sine 120 pi t volts. Find the current through the iron and the power consumed. So this is the circuit diagram from our outlet, goes to the thermostat, then to the indicator, whether it's on or off. That's in parallel with your heating element. So this heating element heats up. Mo na din atong panggamit pang plancha sa ato ang mga kumot na sinina. Okay. To solve for, we are to solve for current and power. So to solve for I, from the previous example, I is just equal to V over R. So that's 220 sine 120 pi t over R is 24. So we have I equal to 9.17 sine 120 pi t amperes. And power is equal to VI. Hence, we have power equal, if we are to substitute, so that's 220 sine 120 pi t times 9.17 sine 120 pi t. So power is equal to 217.40 sine squared 120 pi t watts. Okay. Let's now consider Ohm's law at two extreme values of our resistor. The value of R can range from 0 to infinity. An element with zero resistance is called a short circuit. Based on Ohm's law, the voltage across a short circuit is 0, but the current could be anything. So, diba? V is equal to IR. R is 0, hence V is equal to 0. Now, in practice, a short circuit is usually a connecting wire, assumed to be a perfect conductor. When we say perfect conductor, that is a conductor with zero resistance. The other end of the extreme is when the element has a resistance equal to infinity. That is a very big resistance value. So that element with a very big resistance value is known as an open circuit. If I is equal to V over R and R approaches infinity, then if you are to take the limit of V over R as R approaches to infinity, then we'll have I equal to 0. So this means that for an open circuit, the current is 0, though the voltage could be anything. It's also worthy to note that not all resistors obey Ohm's law. A resistor that obeys Ohm's law is known as linear resistor, while the opposite is the nonlinear resistor, as shown in their respective voltage current plots. On a side note, just in case you wonder, the opposite of resistance is called conductance. Conductance is a measure of how well an element will conduct electric current. The unit of conductance is mho, that is ohm spelled backward. Mho is the reciprocal of ohm. It has the symbol inverted omega. However, the SI unit for conductance is not mho, it is Siemens. It's S. If we are to use conductance in Ohm's law, then Ohm's law can be expressed as I is equal to V times G, or current is equal to voltage times the conductance. Kung ganina, ang Ohm's law in terms of R, so it's V is equal to IR. Let's now consider the power dissipation of a resistor. Diba, from the previous lecture, power is equal to voltage times current. If we substitute the expression for the voltage in Ohm's law, then power can be expressed also as, diba, si V is equal to IR man. So if we are to substitute V, then P is equal to I squared R. Or kung i-substitute nato since si I kay V over R man, so P can also be V squared over R. The power dissipated by a resistor can also be expressed in terms of the conductance G. For that, diba, P is equal to VI, and sa ato ang Ohm's law in terms of conductance, natay I is equal to VG. So, kung atong i-replace si I is equal to VG, so mahimo siyang V times VG. That's why we have V squared G. Or kung si G ang ato ang si V ang ato i-replace, V is equal to I over G. So, natay I over G times I, hence we have I squared over G. Let's have this example. Calculate the current, the conductance, and the dissipated power in the given circuit. Okay, so, di ba, ang power, again, that's equal to voltage times current. Na naman tayo voltage, given naman di ba? Ang voltage across the resistor, across this element is 30 volts. Pareho sa ato ang voltage source. So, ato na lang isolve kay ang current. Current is equal to V over R. So we have 30 divided by 5K, that's 5,000. So that's equal to 6 milliamperes. And power is equal to VI. So that's 30. I is 6 milliamperes. So 30 times 0.006. So we have 180 milliwatts. Or you can also use this expression for power, that is P is equal to I squared R. Diba? Nakasolve naman ta sa I ganina. So I squared R, that's 0.006 squared times 5K. So same gihapon ang answer, 180 milliwatts. Pwede po nga gamitan nato kay ang conductance. And P is equal to V squared G. So anya si G, diba? Kay reciprocal ni R. So 1 over R. 1 over 5K, so that's 0.2 millisiemens. And P is equal to V squared G. V is 30, so 30 squared times 0.002. No, it should be 0.0002. Okay, sorry for this error. And that's equal to 180 milliwatts. And that's it. Thank you for your listening. Next time we'll have the nodes, branches, and loops.